do you guys understand that when we are learning theory, all the concepts we are learning, we are not really learning math?
Yeah.
Okay, do you understand that part?
Yeah, bro.
You understand that part?
Yes.
Okay, so let me just clarify a little bit more thing. So this, tell me if you already knew this, because I think a lot of people are not connecting the dots. So how we have object-oriented programming, it's a concept which can be written in multiple languages, which can be written in Java or C++ or any language. It's a concept versus a language. Both are two different things. Yeah, when I'm explaining, the language and so object-oriented programming concept and the language are two different things, right? Same goes for the concept that we're learning. So the set theory that we covered early in the theory of computing course, that was a concept, and so far we have only been, if think of it like this, if right now we are only used to doing object-oriented programming in just Java, and we are all of a sudden asked to do in Prolog, and we're like, what the fuck do you mean? I'm not sure Prolog supports this, and because our brain is not able to understand that the concept and where you apply that concept is different. Same is happening with a lot of students in theory, because we studied set theory, and now we are used to applying set theory only in arithmetic as in decimal numbers, which go from 0 till 9. That is 1, 2, 3, 4, all the counting numbers, like normal maths. And we do have variables in every fucking thing. But if you remember, if I say decimal math or arithmetic is a certain domain, and we are using set theory to solve that, or when we change the domain that we are working with, say binary numbers, 0 and 1, all of a sudden, because the thing that we are working with, the language got changed kind of. So instead of 1 till 9, now we have just 1 and zeros. All of a sudden, plus minus don't really apply the same way, right? Because these are concepts. And then we test, hey, we establish associative rules and transitive rules, all these rules, to basically figure out what kind of mathematical concepts can we use to work on these kind of numbers. These numbers can be binary or the other thing. And now if you can able to, now you're able to see how decimal, the same concepts of math sometimes apply to decimal, and certain concepts only apply to Boolean algebra or 1 and 0, right? So concepts and the language that we're working with. All of a sudden, Professor Chizar took the concepts of set theory, established the rules to be like, yes, these concepts can be used in this domain, but the domain is neither ones and zeros, not binary, not decimal, but language creation. And the part which gets most confusing is because within the same equation which is written on the board, when he describes the language, okay, you have to apply the mathematical concepts on the language point of view. But when he puts the properties, hey, it can be x equals to y equals to 2x, right? Now all of a sudden, like the properties are sometimes have arithmetic math, or they can have some, like basically the math concepts on language, and the properties when he defines the language, these properties contain arithmetic math and sometimes language math and sometimes binary math, and the switching